Okay, I guess we can start now. Hello, everyone. My name is André Lima. This is EDR Evasion 101, professional hacker red team. Just a quick slide on myself. I'm a red team lead and researcher. And yeah, I started working in Portugal, then moved to Australia, and now here with family. And yeah, if you want to go deeper into stuff and what I think about red teams and such, I've been recently a guest at a control panel podcast with Vebjorn. So yeah, that's the QR code for the podcast. So yeah, not going to go deeply into this because I'm in a bit of a hurry. But yeah, we're going to talk about EDRs. Just quickly, quick notes on names. EDR, endpoint detection and response, basically tool that the agent that will be running on your computer and doing all the detection part. Then you have extended detection and response, XDR, which basically usually is some sort of cross-platform functionality, Linux, or operating systems, blah, blah. And centralized synchronization and management. And then you have NDR, which is usually a third-party SOC team or some sort of SOC team that will be managing the whole thing for you and providing some sort of more advanced analysis on the alerts and all that. We are definitely just talking about EDRs. So from the perspective of the red team, trying to bypass the whole thing inside a computer to do red team stuff. So how does an EDR work? Obviously, it depends on the level of sophistication of the software itself, but most modern ones will, this is an oversimplification, but they will have basically sensors that you can think of as hooks into specific functionalities of the operating system, and then the agent will have the static and dynamic analysis capabilities and will depending on the triggers that comes from these sensors, will deploy analyzing that specific memory region or process, whatever. So in a nutshell, that's pretty much what you're looking at. Also, just a quick note on there's not one thing that will get you, that will trigger an EDR, as in trigger the detection of your payload. Usually, there are a bunch of stuff that will increase the level of suspiciousness. And so it goes from greenish and goes into the red area. And it depends on the EDR. They will have set the bar at different stages around the orange and red, and so will trigger then. And this is one of the reasons why techniques such as process migration is so important, because if you just start your executable, let's say whatever .exe, and you start doing weird stuff, the fact that you started a not signed application process that will do suspicious things will just start piling up in this graph and will easily get you into the red zone. As opposed to you doing process migration, migrating your code, your shell code, for example, whatever payload, DLL and whatnot, into another process, and then starting doing things inside in the context of that process. You will have, if you think about if you're a rootkit, if you're simulating a rootkit, you probably want to go into something like explorer.exe because then accessing the hard drive is pretty normal. And if the EDR is seeing that explorer.exe all of a sudden is reaching out to all these files, that's kind of typical behavior that happens very often. So the suspicion will be a lot lower. And if you want to reach out to the network, if you do it from explorer.exe, that's suspicious. If you do it from a newly started process, that's suspicious. But if you do it from MS Edge, from Firefox, from Chrome, then that tends to be a lot more normal behavior. So yeah, it's gradual. It's not one definitive thing that will get you picked up. So just to go into the components, sensors, if you will, of the EDR, you have the mini filter driver. This is basically, not to go into technical detail because it gets very complicated, but Windows have the structure that the requests for file systems in terms of reading files, accessing, writing, whatever, executing, all go through this process where the mini filters will be in the middle and will be able to, as callback functions, kind of execute code and process whatever. A typical example is the BitLocker mini filter, which will encrypt everything and decrypt everything, encrypt everything that goes down and is written onto the hard drive. And when you are trying to access that data and it comes back up, it decrypts it in the middle. So that's a typical mini filter. And of course, EDRs will have that and they will detect it. They have to keep it above, obviously, BitLocker because you don't want to analyze the data after it's been encrypted, but you will have the EDR mini filter above it, and it will analyze the payload, see what is this file that has just been written or put into the file system. So that's mini filters. Then you have kernel mode driver, which will add a lot more information in terms of kernel into the EDR part. There are callbacks in the kernel that you can have, that you can set up programmatically, where you will, as soon as a new process comes up or whatever, and that information will be conveyed to the EDR, and it will tell the EDR, hey, this is a new process that just started, and these are the parameters. Go analyze it and do whatever you want, and figure out if it's a good thing or a bad thing. And that's how the EDRs will typically know magically that a new process has started, is through these kernel mode driver callbacks. So yeah. Then you have obviously network filter, which, as the name says, will analyze stuff going in and out the network, which is very useful because sometimes even when you're successful at bypassing the EDR locally through the mini filter and the kernel mode driver, if you're reaching out, I don't know, Metasploit on your network and it's using a default certificate, then that type of stuff will be usually detected by the network filter and it will say, okay, so this guy is doing something with Metasploit. We definitely don't want that. So let's check on what's this process that's starting this communication and all that. Then you have the ELAM driver, that's the early launch anti-malware. This is more related to bootkits, sorry. But yeah, it's a bit out of scope of EDR Evasion 101. It's a bit more advanced, but yeah, just so you know. And also ETW, that's the event tracing for Windows. And yeah, that's a lot of logging information that goes into processing all the information. So for EDRs. Now, approaches to evasion. You can think of it as if you think about the agent with a bunch of sensors throughout the whole system, you can think of it as trying to disable one or multiple sensors, so then you can act on whatever. If you are able, for example, to disable the sensor that detects that a new process has started, you can then start as many processes as you want, and it probably will not trigger an analysis of the EDR onto that payload. Of course, you can do that with minifilters or whatever, but also you can think about disabling the agent responsible for the scanning. So even if a sensor is triggered, but it sends the information back to the EDR, but EDR is not running for whatever reason, then you're good to go. I'm actually going to show you something like that. Or you can just simply not care because you are invested in techniques that will bypass the sensors and just avoid detection altogether. I'm kind of going to have a walk through that whole process with that. Just full disclaimer, this is not the full encyclopedia on EDR evasion. It doesn't mean that just because I'm showing you something, it doesn't mean it's the best solution. It's just a solution. And I'm going to, most importantly, explain the logic behind it and not so much this is how the Bible says it should be kind of stuff. This is not at all that. But just so you can understand the logic, and feel free to ask questions at any point in time. So yeah, first things first, figure out what in which area are you developing the payload for. This might seem like you have a lot of freedom, but sometimes you would, most of the times, especially in the industry, what you try to emulate is mostly what the attackers are trying to do. So obviously, most people will use Windows. So Windows will be the most where you find more viruses and all that. So typically, you will have to have some sort of skill set in developing malware in Windows. Linux is also a thing that can be a specialization. There's definitely very few people doing, for example, stuff like rootkits in Linux. And yeah, then you have to figure out the assembly as well. X64 is usually the most common one, but ARM obviously is becoming a thing. And yeah, the language that you want to deploy in it. C Sharp, .NET tends to be a bit less sus and in terms of like how likely it is to be a malware because it mixes up a lot better with the whole environment. But you can do stuff with C as well. That's just fine, especially if you're doing process migration and injecting yourself into other processes, like who cares? Rust is the new thing. They're not big advantages, I think. Happy to be convinced otherwise, but of developing stuff in Rust. Because if people are doing hashes on payloads just blindly, then yeah, that's the worst way to go about it. I do a lot of Rust. I'm a huge fan of Rust, but for other reasons, high performance fuzzing, blah blah, other research areas. But in terms of developing malware, it's not exactly a big advantage there. But definitely something you should learn. More specifically, there's a lot of malware that is going to start being developed on that, and you need to understand it, blah, blah, its advantages and all that. So yeah, huge fan of Rust. Um, Also understand that there's what I like to call the dynamics of specialization. Because most of you, I would assume, are students, you need to understand that the simple dynamics of if I know nothing and I decide to become a Windows specialist, it will probably take me rough numbers, 2, 3, 4, 5 years in order for me to know more than the majority of people in this room. If I decide to go do something very niche, such as hardware hacking, in probably 1 week, I will know more than most people in this room. So it depends on the area, and that's where people will often come to me and say, "So should I learn like x64 or ARM?" I'm like, "Learn both. What are you talking about? If you, oh, but Rust is complicated. Go figure it out. That's just time, and you will be really good at it. It's always an advantage, and just go for these things." I draw the line. There is a realistic approach to it. I draw the line, and I started many years ago. Started writing rootkits in Linux, and I was like fascinated by the capabilities that I had and all that. But then I was like, wait, like, do I want to spend a lot of time on this, or just jump into Windows and become really good with Windows? And then I started developing rootkits in Windows and all that. And at this point, human brain, like in the consulting world, they sell people as experts and they pretend that that's something that you can just, I learned something, and then you can package that, put it in a freezer, and at any point in time, you can just pop it out and you're magically the expert. In truth, if you're actually an expert at anything, you know that doesn't work exactly that way. I will dig deep into, I don't know, ARM or something, and if I don't touch it for 6 months, I will know nothing about it at some point. So yeah, just understand that the dynamics of specialization. But yeah, just a quick tip. Now, quick notes as well that I'm going to go very quickly to attack surface recon. It's a bunch of commands. Basically, you have to do this in order to try to map out what are the processes that are running that belong to the whatever EDR that you're testing, that you're trying to bypass. By the way, I'm in my labs. I'm basically going to use Defender. This is not to say it's better or worse. I'm not making that comparison. I'm a scientist at the end of the day, so I would have to be very thorough. So I don't like to be unfair here. But yeah, so I'm targeting a defender, but you kind of have to do this work in whatever EDR you're targeting in. But yeah, just trying to figure out what processes, what services, what files, what drivers does it map to in the hard drive and all that stuff. That's a whole recon process that can go very, very deep. So yeah, FEL TMC, that's for mini filters, and you can see the WD filter is up there with a higher altitude because I believe the BitLocker one is the file crypt below, so it makes sense to be at a higher altitude, so it analyzes the data before it goes into the encryption part. But yeah, just getting information about the mini filter, getting information about processes, blah, blah, all this stuff. And then I get the information about the specific version that is running. And you might ask, what do I care about the version? I just want to bypass the thing. Like, who cares? But the thing is, if you know the version, you can go into C program data, Microsoft Windows Defender platform, and the version will be the folder name. And you can get the exact versions of the EDR engine and the exe, DLLs, blah, blah, whatever it uses. And this is super important because there are levels to this analysis, to this recon. You can do a very basic recon, such as I just showed you with the simple commands, or you can actually try to reverse engineer the whole payloads from the EDR and try to see exactly what they're doing. The deeper you go, the more things you'll find, blah, blah, all this stuff. And you often find bugs in these. So yeah. Now let's start with bypassing static analysis. This comes down to avoiding being detected by Yara type of rules, where you kind of know what to expect in terms of detection engineering, and then you try to obfuscate the code to bypass it. Quite frankly, this is the easiest one. You just write some C sharp, whatever you want, code, and you can even have meterpreter type of payloads in there that are spit out by MSF Venom, for example, or whatever C2 you want. And if you just let it like that, it will be detected, but immediately as soon as it touches the hard drive. But if you just do a basic obfuscation, you won't. Also, just a quick note, understand as well what is your goal, because a lot of times you try to complicate things because you learn it a specific way. Oh yeah, that it's an interpreter that I have to use or whatever Metasploit, and then you try to spit it to use it, and instead, like, Meterpreter has a ton of functionality, and the price you're paying is that that will most likely be detected at some point. So the question is, if you're just doing a red team and the goal is just to steal, I don't know, a flag because you agreed to that with the client to prove that you could access like a specific server, or just access a file or somewhere you know exactly what you're doing, you can write very small shellcode that will address exactly that and will bypass everything, because if you write your own shellcode, you won't be detected. So yeah, just to highlight the goal part. Uh, um, Now, payload one that I developed, that I wrote, is known shellcode and no static analysis protection. I'm going to start going a bit faster, otherwise I won't be able to finish. But yeah, that's very basic code. You'll see the shell code is in the buff array, and I do very basic process migration there. And yeah, the code is being generated with MSF Venom. That's the shell code. And lo and behold, if you just do that, you will trigger the EDR every day of the week. So now on the payload 2, there is known shellcode still, but there's static analysis protection and dynamic analysis protection. And on this one, the dynamic analysis the static analysis protection is basically a very simple XOR key encryption. And a lot of people, just one second. So yeah, that's the code that will you have the payload above, and that's the code that decrypts the thing before actually running it. And people usually tend to assume that, oh, but this is very basic, Andre. Like, anyone will be able to analyze this. The thing is, you have to distinguish between two types of detection. One is automatic detection, which you definitely are actually trying to avoid, and the other one is, will a really good malware analyst figure out what I'm doing? A really good malware analyst will always figure out what you're doing. They figured out what Stuxnet was doing. They will always figure it out. But the realistic time frame for that to happen is it has to go through a bunch of automatic tools that will then say, okay, we can't figure out what this is doing. So put it on the pipeline for someone who has a life, who has a job and is stuck in traffic and is stressed with life, then goes in there and lo and behold, 1 month, 2 months goes by. And then, okay, yeah, this does something and I've used my really good skills and then it flags it onto something. And then you might be detected months later after you've developed the payload. So there's a realistic thing. And this, you might think, oh, but this is actually really basic. Like, are you sure like automatic tools are not detecting this? Well, you can always overcomplicate it a little bit, but people tend to come up with these, oh, we should use like AES or some really military grade encryption with it. That's some really advanced stuff. And it's usually mostly people trying to show off how smart they are by overcomplicating things. And I hate that. But I'm very scientific based. I don't do more than I have to. And I need to understand, like, if I see an EDR detecting something, then I know it's detecting it, then I need to push forward. But I won't do that and just waste my time because if you do that, you can infinitely just spend time on everywhere. And this is admission from Microsoft. I have the link below where they yeah, themselves are saying at this point, we're generally past, this is a basic Zora encryption. Just for context, this is an AMZ, why you should use AMZ blog from Microsoft. And they're basically showing you how to encode the script more and more to the point that they get to the most advanced version, which is the Zor 1 byte Zor encryption, which is exactly what I'm doing on my malware payload. And they then go, at this point, we're generally past what antivirus engines will emulate or detect, so we won't necessarily detect what this script is doing. That is admission because, and if you think about it, it makes perfect sense. It's not like it's already a tremendous amount of work for an EDR to just go through every single memory page on the operating system, or the suspicious ones at least, new ones and so on, and analyze all those bits and bytes all together. If you think they're doing that and they're encoding that with all the possible 256 keys in 1 byte for one ZOR to see all the variations of it, not a chance. That's not realistic. That is not happening. So again, don't overcomplicate. You can make a bit more complex version of this, but you don't need to. Now, to talk about the bypassing dynamic analysis. There's a whole bunch of techniques. I'm not going to go into each of them, but I wanted to highlight there is one that is where the image is very small. I'm going to zoom it in soon, but it's reach out to non-existing URL. The whole point is that once you double click on an executable, you started the process, it will basically, start a sandbox. EDR will have a sandbox that will run the thing for a couple of seconds, a few seconds, depends on EDR. And it will look at all the Windows API functions that it's calling and try to figure out if it's doing something suspicious. Very basic trick that I use. For example, back in the day, people would use a lot of sleep just to delay that process. And after, like, if you use a sleep of 3 seconds and the sandbox is only running for 2 seconds, it's not going to detect before you start doing bad stuff. It's not going to detect it. So what people do is they start, what EDR started doing is they just emulate the sleep and there's no sleep inside the sandbox. So it just starts, jumps to sleep and executes right away. So what you do as a malware writer is you set up a timestamp before you get the time and date before, and you run a sleep of 2 seconds, for example, and then you get the time right after. And then you compare those two times that you caught before and after. And if it's roughly in the range of 2 seconds, you know that the sleep was actually executed properly, not inside a sandbox. And if you notice that it's a lot lower than the 2 seconds, then you know something fishy is going on, someone is hooking something. So that is how you detect, that's one way, one of a million ways to detect that you're running inside a sandbox. Another interesting way is the sandbox will emulate behavior, and it cannot implement the whole operating system, obviously, inside the sandbox. So it will do fake stuff, like if you ask for www.banana182.com, that probably doesn't exist, definitely, but it will say, yeah, it does exist. It went well, and you will keep running. So by doing that, a randomly generated URL, you will figure, and if it says it does exist when you know it doesn't exist, you will know that something fishy is going on, that you're probably being inside a sandbox, so you don't execute, you just do an exit, a return zero, or whatever. Now, I just wanted to highlight something interesting, which is in WannaCry. A lot of people assume that there is a fail-safe feature into it. Let me show you that.
Do you want to show that?
Oh, yeah. Oh. Okay. Yeah, let me just quickly HTTP, I think. That's here. Now, let's go to the cross-reference. Yeah, there you go. So if you look at this piece of code, it establishes a URL, which is a randomly generated one, and it comes here and it checks if it did work. And if it did work, which it shouldn't, it will just stop execution because it assumes that it's inside a sandbox. Now, the thing is, people looked at this and people assume that it's a fail-safe, like it's a responsible party that decided to do this so that, and the person who detected this, first analyzed this malware tech, I want to say, I forgot his name, a British guy, but he just registered this and made it exist so that when it actually ran, it basically stopped this whole ransomware from running. But people automatically assume that you did this because you're a responsible actor. So therefore, they assume that you're the United States of Americas of the world. Okay. But the whole point is that this is typical sandbox bypass behavior. And so my point is you don't know. Maybe it's just an irresponsible one, but they were doing their sandbox evasion. So definitely going to speed this up. But most importantly, as soon as you know anything specific about your target, your machine, then it's basically game over. If you know the host name, if you know the domain you're supposed to run in, any type of specific information, you're good. So yeah, that's the sleep trick that I was showing you. And yeah, when I run it, I just have there the process ID so that I could then. So one thing, I was expecting Defender to detect this, and it didn't. Because I was expecting that it would do some sort of memory scanning, and because it's a known shellcode, it would detect it. Now, it didn't, which was a surprise. So I kind of found like another tool, which is a PEC from Hasherazad on GitHub. She's amazing, does amazing tools. And I use the tool, and lo and behold, total suspicious is 1. So you can see that it does detect the thing.
And we're not over time.
So
if he skips to the last slide.
Okay. So yeah, just putting it all together, custom shellcode, which luckily Trim is going to present after. So you jump into more details about this. Yeah, I won't show you the demo, but yeah, I'm using Keystone engine here just in Python to emulate it, and it spits out the shellcode. And when I try to use that instead, then you see that there is no suspicious code anymore. And yeah, just also highlighting the fact that because I wrote my own shellcode, there's this hash algorithm that you can write that everyone in the world that writes shellcode usually just copy paste stuff. And especially if you'll notice this if you use AI, it will give you that algorithm. And the algorithm is basically to find out strings like API functions, like create process A, for example. But the thing is, you don't want to have the name of the function to go and check on the DLL to find it and then call it. So what you do is you compact that into a hashing algorithm. So you have just 4 bytes, and you then calculate for each string that you find the hash, and you compare those hashes. And if the hashes match, it means you're in the right API that you want to call. Now, everyone in the world uses what is called a rotate right 13 algorithm. For whatever reason, someone decided, and everyone else copy paste for it. Now, because I was converting my old shellcode from 32-bit to 64-bit, I just looked at that, and out of the blue, I just decided, let me make this fun and just write my own algorithm, which I made up. The advantage is every malware analyst in the world knows that they can grab one of those hashes that they find in shellcodes, and they can Google them, and they will find, oh, that's great process. Oh, that's close handle. Oh, and they will know what the shellcode is doing. As opposed to mine, where you check for the hash and you will find nothing, so there is 0 clue. So that's a big advantage in developing your own shellcode. And yeah, I won't have time for this. Yeah, I wanted to demo basically there's a legitimate driver from an EDR called Avast a few years ago that was found a vulnerability in that you can install it, and it has the functionality of a rootkit killer. So it will kill any process that you send the process ID to. I was going to show you how to do the reverse engineering on Binary Ninja, but whatever. Could show you guys if you're interested, just ping me later. But yeah, you can then figure out how to contact this driver and tell it to kill other processes. And I can kill stuff like Defender itself, MSMP engine. But yeah, that's a demo for another day. So yeah, I don't go into a lot of details in rootkits because you can go to YouTube and you'll find a few previous presentations of mine on other B-sides, also in Lisbon. And also the professional side of it is basically proper documentation. If you don't do documentation, that just means you're not experienced because no matter how smart you are, no matter how good memory you think you are, you're not memorizing this whole thing. You have to have proper documentation system in order to go through it. And the automation part, I'm not going to go into because there was a presentation as well. So, and besides also. So yeah, just a quick tip. I'm going to make this simple. Yeah, master RE reverse engineering skill set. That is the basic language of it. I noticed that today I can understand very advanced concepts, whatever is thrown at me, because I understand I have really solid background in reverse engineering. I have done courses on rootkit, and the instructor was doing what I deemed as some sort of dark magic that I could not understand on WinDebugger, blah, blah. And lo and behold, it wasn't that I wasn't smart enough. It's just I didn't have the right background. So I went back and I studied reverse engineering to the point that where I went back to the program again, to the material. I was like, oh, that's what he meant. So again, the biggest tip here, definitely EDR, reverse engineering. Yeah, just wanted to show you a few really good books. If you're starting, definitely the IDA Pro book. The Windows kernel programming is also amazing for you to write kernel drivers on Windows. Practical reverse engineering is also amazing for you to learn to analyze rootkits and such. Yeah, just read them if you can. Yeah, some YouTube stuff. That's Hasharazad, the author from the tool that I use, PC. OA Labs is the best reverse engineering channel on YouTube by far. The other ones are fun. Anush Soni has a bunch of stuff on Binary Ninja, which I'm a fan of. We can talk about it later if you want. And yeah, thank you very much. You can reach out to me on LinkedIn. That's the QR code. And if I see you on Secrets Festival, I'll be presenting there malware detection with hypervisor one. Yeah, the type of hypervisor. So thank you.
Thanks, André.